this is the Squidstat machine here, this red box. See, the only button you need to worry about here is this one in the front. That's the power button. Once it turns green, you're going. So it works with these 5 connector points here. These 2 red ones are for the working electrode. So this one with the white end and the red box is the sense working electrode lead. So this is used to take measurements. This will record current, voltage, all that kind of stuff is recorded through this cable. And this one is just the working lead. This is to apply voltage or current. And you can see these also, the clips can slide off. So you just have the prongs to attach to different things. And you can also use this box to double up so that both cables go through just this one connecting point. And so most of your experiments will be done with this kind of a setup. The other 3, we have these 2. This is also a sensing lead, and this is to apply voltage and current. The only difference is that these are for the other electrode. It's like the other one, you can take the clips off, and the application lead can be slid into the sensing lead. Then the green one, this is our reference. This is just how we're going to determine where 0 voltage is or 0 potential. So generally for a 2 electrode setup, you'll set it up like this with the reference on top of the counter leads and the working leads stacked together like this. That way you just have 2 connecting points. This one for your positive end, this one for your negative end. So once you've got everything set up on the machine, you can come over to the computer, and the software is right over here, the Squidstat user interface. So once that opens up, you'll have the Run an Experiment tab with all these different categories of experiments. So we are going to start with the chronoamperometry, and all the parameters for all the different experiments will show up right here. So this one will apply a constant current for a specific amount of time, which we can specify here to be 1 minute. And we can also specify how often it will take a sample and what potential it's going to apply. So then once we have all our parameters figured out, we can attach our sample. In this case, it's just a resistor between the 2 leads, and we need to make sure that there's no electrical contact between our sample and anything else. So that's really important because we have a metal table here that we're working on. So if you can find something to prop it up, that'll help you out. So then once you've got that set up, you hit Start Experiment. So once you hit Start Experiment, it'll pull up this sheet of cell parameters. You could ignore this and just click Do Not Apply Skip. It'll bring you to this stage where you can go ahead and select a name for your test and what file you're going to save it to. Then once you hit save, the experiment will start. So it'll immediately start generating data in a graph here. And you can change this graph. There are a bunch of presets. You can do voltage, current versus voltage, current versus time. Generally, the most logical graph will already be selected, but you can select different axes and data to show up on your graph, which you can then export as an image, aside from the Excel file that will also be saving to the file you specified. Just cut this part out so that it skips to the end of the experiment later. So yeah, once it's finished, it'll go ahead and stop. The green light that was up here will disappear. You can see we have all our data here on the graph. So we can see as the potential was applied, current kind of increased, but not really, because it's moving by about a couple thousandths of a milliamp, which is what we'd expect since all we're doing is testing a resistor. So now there's one other important thing that this device can do, and that is electrical impedance spectrophotometry. So to test this, we're going to switch and do a capacitor. So the wire setup will remain the same. We hook this up. So then there's all these parameters here. Quiet time is how long it'll spend at the base potential before starting. Your sampling interval, then starting frequency, the frequency of alternating current that you'll start at, and the ending frequency. It will work from top to bottom. Anything below 1 hertz will start to require a long time to take a reading. So below 0.4 hertz, I would avoid if you can. Says per decade just tells you how often it's taking data. Then this is the potential that is applied constantly throughout the experiment, and this is the excitation potential that it will be using with these frequencies. So generally 500 millivolts is a reasonable value. You don't want this to be very high in case it causes a significant impact in current. And the number of sample cycles is the amount of data points it collects at each frequency. Then this right here is just going to generate lots of different data sheets instead of one Excel file if you hit yes, so it's generally more convenient to hit no instead. So once you've got all that set up how you want it, and you've got your capacitor hooked up there on the leads, you can start the experiment. Skip all of this again. Save your file. And it will start. So the default for EIS experiments is a Nyquist plot. You can also switch it to a Bode plot if you so desire. And over here you can see what it's currently working on and what the last data point was. So you can see it's now at about 1.2 hertz. Once we get below 1 hertz, it's going to start taking significantly longer to get new data points. The smaller the frequency is, the longer it generally takes to get a new reading. And it will go to 400 millihertz, which was our bottom frequency for the test. Finished. So you can see this is a regional plot of what we'd expect for a capacitor. An ideal capacitor would be a vertical line, but since this obviously is a real capacitor, not an ideal one, this kind of line slanted out towards the right is what we'd expect to see. And then once you have all your data, it all saved already, you can just hit close all grafts. It'll close everything. You can close out the software, then turn the instrument off, remove your sample, and separate all of the leads again, and you can go ahead and put the alligator clamps on so that they don't get lost in storage. And that is how you use the Squidstat.